All right, I wanted to quickly do one more thing with you. I said we were done in the last video, but I forgot about Mathematica. So what I've got here is a linear system, three equations, three unknowns, and I've gone ahead and written down the augmented matrix as well. I named it A. So there's that. And if you remember Calc 3, each of these equations corresponds to a plane. So when we're trying to solve this system, we are looking for a point that lies on all three planes simultaneously. And so let's go ahead and graph this. I'll scroll up where you can see this a little bit better here. So there it is. Here's the three planes, and if you look, any two planes that intersect as a line, so we can see the intersection line of the green and blue plane. You can look down that line and see that it does shoot through the orange plane there as well. So we can see that there is a solution. There's a unique solution, and I've actually marked it with the little green dot there, so you can kind of get a sense of where it is. We're all upside down here with our axes. It looks something like it might be living on x equals 0, and z is something positive and y is something positive as well. I'm not sure why the color changes when I turn, but it does. Okay, so you can see the solution. That's what's happening. This is the matrix that corresponds to our system. So what I want to show you now is that if you go ahead and perform row operations on that matrix, we'll talk about how to do this a lot next time in 1.2. But there's a way using elementary row operations to reduce our matrix A to this matrix right here. And I want you to realize that the solution to the original matrix is the same as the solution set to this matrix because row operations don't change solutions. So think about the equations that correspond to this. The first one says x1, or I'll just say x in this context, x1 is 0, x2 or y is 2, and x3 or z is 3/2. And that's it. And so I've actually graphed those. I have those equations written down here, and we can graph those. And you can see, oh, they're all just coordinate type, not coordinate planes, but shifts of the coordinate planes. And the intersection now is crystal clear. You can see it. I've actually got the same green dot, but it's not showing up. Let me scroll up a little bit better where you can see it. So all that row operations do is they allow us to change the form of the matrix, which changes the linear system, but not the solution. And this particular form is really nice because it gives you a super clean linear system, which graphically is very easy to read off the solution. You can read it off graphically, you can read it off the matrix as well. So we're going to really like when we can put our matrices in this form where there's ones down the diagonal, zeros off the diagonal, and then our solutions just sit right there. When you have this form, you can read off the solution to your linear system. x1 is 0, x2 is 2, x3 is 3/2. So more on this next time. We really are done with 1.1.